Hey everyone, and welcome back. Today we're going deep on alcohol and the brain.
Okay.
Um, it's kind of a scary topic, but also super fascinating.
Oh, absolutely. I mean, it's something that most adults have some experience with, right?
Yeah.
But when you really start to dig into like the science of what's happening, it's kind of mind-blowing.
Totally. So, we always start these deep dives by like looking at all the research out there
Hmm.
and pulling out like the most interesting bits, right? So
Yeah.
so we're not going to like rehash like, basic stuff that everybody already knows, but we will we'll cover some kind of like surprising stuff
Yeah, for sure.
for sure.
I think one of the most surprising things for me was learning about how alcohol actually works in the brain. Like, it feels like a stimulant at first, right?
Yeah.
Makes you like more talkative, more confident, more
Yeah. Loose
outgoing.
and relaxed. Yeah.
Exactly. But it's actually a depressant. It's depressing your central nervous system.
Wow, it's like a trickster.
Yeah.
Like it makes you feel more, kind of energetic at first, but
Yeah.
really it's starting to shut down parts of your brain.
Exactly. And that's what's so fascinating, right? It's like it starts by affecting these higher level functions,
Hmm.
like your inhibitions and your judgment. So one of the first areas it hits is the cerebral cortex.
Oh, okay. So the cerebral cortex.
Yeah, which is kind of like the control center of your brain. It's responsible for processing information from your senses,
Right.
making decisions, controlling
The
movements.
higher level thinking.
Exactly. And as alcohol starts to like act on the cortex, your judgment gets cloudy,
Hmm.
you might find yourself making those impulsive choices you wouldn't normally make.
Oh, like beer goggles. That's the cortex talking.
Exactly, exactly. It's not just your inhibitions loosening up,
Mhm.
it's your brain's ability to make sound judgments that's actually being impaired.
So is that why people do things when they're drunk that they later regret? Like, is that because their cortex is not really functioning at full capacity?
It definitely plays a role. It's not the only factor, of course, but it's a big one.
Wow, that's crazy to think about.
It is. And then from the cortex, alcohol continues its journey to the cerebellum.
The cerebellum.
Yeah, which is the part of your brain responsible for coordination, balance, smooth movements.
Oh, okay. So like your physical coordination.
Exactly. Have you
Yeah.
ever noticed how like a couple of drinks can make you clumsier?
Oh, for sure.
Yeah.
I definitely have some personal experience with that.
Right. Makes fine motor skills a bit trickier. Maybe you feel a bit dizzy.
Yeah.
That's alcohol affecting your cerebellum.
It's kind of scary how much it affects your physical ability.
Oh, absolutely. I mean, that's why driving under the influence is so dangerous. Like alcohol's effects on the cerebellum,
Mhm.
it significantly impairs reaction time, coordination, your ability to make those split-second decisions.
Yeah, it's just not worth the risk. But, we've talked about like physical coordination and judgment. What about memory? I know alcohol affects memory too, right?
It does. It does. And that takes us to the hippocampus.
Or the hippocampus.
Yeah, that's another key stop on alcohol's brain tour.
The hippocampus is like the memory center of the brain, right?
Exactly. It's responsible for forming new memories. And alcohol can really mess with that,
Yeah.
especially with like, long-term heavy alcohol use.
Okay, so like those times you can't remember someone's name or you like lose your keys after a night out, that's alcohol affecting the hippocampus.
It could be. And the scary part is that heavy drinking over time, it can actually damage the hippocampus, leading to lasting memory problems.
Oh, well.
Yeah, there's a growing body of research showing a direct link between heavy drinking and shrinkage of the hippocampus.
Shrinkage.
Yeah, shrinkage. Like the hippocampus actually gets smaller.
So it's not just like temporary impairment, it's like actual physical damage.
Exact.
That's really scary.
Yeah.
So are there other long-term effects on the brain from alcohol?
Unfortunately, yes. There are other serious risks, including Wernicke-Korsakoff syndrome.
Wernicke-Korsakoff syndrome.
Yeah, it's sometimes called wet brain, but that's kind of a misleading term. But it's a condition that's often caused by a thiamine deficiency, which is common in heavy drinkers.
Thiamine.
Yeah, it's a vitamin. And it's essential for brain function.
Okay.
And Wernicke-Korsakoff syndrome can have severe and lasting effects on memory, coordination, cognitive function.
So we've talked about how alcohol affects different parts of the brain
Right.
and some of the short-term and long-term consequences.
Yeah.
But how does it actually do all of this? Like, what's the mechanism behind all this disruption?
Well, you know how we've been talking about the brain like a complex network?
Yeah, with billions of neurons sending signals back and forth.
Exactly. Well, the messengers that facilitate this communication are these chemicals called neurotransmitters, and alcohol messes with that balance.
Oh, so it's like disrupting the communication lines in the brain.
Precisely, it throws things off.
Okay, so what neurotransmitters are we talking about here?
Well, two key players are GABA and glutamate.
GABA and glutamate.
Yeah, you can think of GABA as the brain's like chill pill. It calms things down, slows neural activity. Glutamate, on the other hand, is like the gas pedal. It excites the brain, increases communication between neurons.
So does alcohol boost GABA to make us feel relaxed
Yeah.
and suppress glutamate to, like, slow us down?
It's a bit more complicated than that. It enhances the effects of GABA, making the brain even more inhibited.
Okay.
At the same time, it suppresses glutamate, which further decreases neuronal activity.
Wow, so it's like hitting both the brakes and cutting the engine power at the same time.
Exactly.
No wonder things start to go haywire. And I'm guessing this disruption of GABA and glutamate is also involved in how alcohol becomes addictive.
It definitely plays a role. But it's not just those two neurotransmitters. It also affects other neurotransmitters, particularly those involved in the brain's reward system,
Right.
like dopamine and serotonin.
Oh, the reward system, that makes sense. So alcohol triggers the release of dopamine, which makes us feel good.
Exactly. Even small amounts of alcohol can increase dopamine levels in the brain, especially in areas associated with reward and pleasure.
So that's why we like it, right? It makes us feel good.
Right. And this is where things get really interesting. Certain variations in our genes can actually make some people more sensitive to these dopamine-boosting effects of alcohol.
Wait, are you saying our genes can influence how susceptible we are to alcohol addiction?
Precisely. It's not just about willpower or making bad choices. Our genes can actually predispose us to addiction.
Wow, that's kind of a game changer. So it's like some people are just wired differently.
In a way, yes.
That's pretty mind-blowing. But what about serotonin? What role does it play?
Serotonin is another neurotransmitter that's affected by alcohol. It's involved in mood regulation, sleep, and other functions. And alcohol's effect on serotonin is a bit of a double-edged sword. It can initially boost serotonin, leading to feelings of euphoria,
Oh.
but chronic alcohol use can actually deplete serotonin in the long run.
So it's like a short-term mood lift, followed by a potential long-term crash.
Exactly.
Wow, this is all incredibly eye-opening.
It is, isn't it?
I'm starting to see alcohol in a whole new light.
And that's exactly the point of this deep dive, to empower you with knowledge so you can make more informed decisions about alcohol and your health.
Well, I'm definitely rethinking my relationship with alcohol after all of this.
Good. It's important to be mindful of the potential risks and to make choices that support your well-being.
I agree. Thanks for sharing all this incredible information.
It's my pleasure. And we're just getting started. In the next part of our deep dive, we're going to explore how alcohol tricks the brain into needing more and more, leading to that vicious cycle of tolerance and dependence.
Well, that sounds intense.
It is.
I'm a little scared, but also really curious to learn more.
I think you'll find it fascinating.
All right, well, I'm ready when you are.
Let's do it. All right, welcome back. So last time, we left off talking about how alcohol affects these different parts of the brain, like the cortex, the cerebellum, the hippocampus.
Yeah, it's pretty wild how it kind of messes with everything.
Right. And we talked about those two key neurotransmitters, GABA and glutamate, and how alcohol basically throws their balance way off.
Yeah, like hitting the brakes and cutting the engine at the same time. I'm still kind of reeling from all that.
It's a lot to take in, for sure. But now we're going to delve even deeper into this whole addiction thing.
Oh, okay, addiction. I mean, I know it's a huge problem, but I don't really understand, like, how it works in the brain.
Well, one of the most groundbreaking discoveries is the role of genetics.
Genetics, you mean like our genes?
Exactly. It turns out your genes can actually influence how vulnerable you are to becoming addicted to alcohol.
Whoa, wait a minute. You're saying some people are just, like, predisposed to addiction?
It's not that simple, of course. Addiction is complex. There are multiple factors, but genetics definitely plays a role.
I mean, that kind of changes everything. Like, if it's in your genes, what could you do about it?
Well, first of all, it's important to remember that genes aren't destiny.
Okay, so it's not like a guarantee.
Right. Having a genetic predisposition doesn't mean you'll definitely become addicted.
Okay, that makes me feel a little better.
But it does mean you might be more susceptible. So being aware of that risk can help you make informed choices.
So, like, if you know you have a family history of alcoholism, you might want to be extra careful with alcohol.
Exactly. It's all about being mindful and making choices that support your well-being.
Okay, that makes sense. But can you give me some, like, specific examples of how genes might be involved?
Sure. Let's talk about the dopamine system, for instance.
Dopamine, right? The feel-good chemical.
Exactly. And remember how we talked about alcohol triggering a surge of dopamine?
Yeah, and the reward system.
Right. Well, there's a gene called DRD2.
DRD2.
Yeah, it codes for a type of dopamine receptor in the brain,
Receptor.
like a little docking station for dopamine. And variations in this gene have been linked to an increased risk of alcohol dependence.
So are you saying that some people have like different versions of this gene that make them more sensitive to dopamine?
That's the idea.
Wow, so they get a bigger dopamine rush from alcohol,
Yeah.
and that makes them more likely to want more.
It's a simplified explanation, but yeah, that's the general concept.
That's incredible.
And it's not just dopamine. There are genetic links in other neurotransmitter systems as well.
Like serotonin.
Exactly. Variations in the serotonin transporter gene,
What's that called?
it's known as 5-HTTLPR, have been associated with how people respond to stress.
Stress.
Yeah, and also how they metabolize alcohol.
Oh, wow. So you're saying our genes can even affect how our bodies process alcohol.
Yep, it's all interconnected.
My mind is blown.
I know, it's fascinating stuff. But let's move on to another crucial aspect of alcohol's effects: tolerance and dependence.
Oh, okay. I've heard those terms before, but I'm not really sure what they mean.
Well, tolerance basically means that over time,
Uh-huh.
you need to drink more alcohol to get the same effects.
Oh, right. I've heard people say they have a high tolerance.
Exactly. It's like your body gets used to the alcohol, so you need more and more to feel the same buzz.
Okay, that makes sense. But what about dependence?
Dependence is when your body starts to rely on alcohol to function normally.
Oh, so like you need it just to feel okay?
Right. It's like your brain has adapted to the constant presence of alcohol, and when you stop drinking, it throws everything off.
That sounds pretty scary.
It can be. Dependence can lead to withdrawal symptoms.
Withdrawal? Like what kind of symptom?
It varies. Some people experience mild anxiety, insomnia, tremors.
Right.
Others have more severe symptoms, like seizures, hallucinations, even delirium tremens.
Delirium tremens. What's that?
It's also known as the DTs. It's a very serious condition. People get really confused, agitated. They might even have visual hallucinations.
Wow, that sounds really dangerous.
It is. It can be life-threatening.
So how does this tolerance and dependence thing happen?
Well, remember how we talked about alcohol messing with GABA and glutamate?
Yeah, the neurotransmitters.
Right. Well, over time, your brain tries to compensate for the alcohol. It's like it's trying to fight back.
Okay.
It starts producing less GABA and more glutamate to try and restore the balance.
So it's like a tug-of-war between the alcohol and the brain.
Exactly. But as this goes on, your brain becomes less sensitive to alcohol, so you need more and more to get the same effect.
That's how tolerance develops.
Right. And at the same time, your brain becomes physically dependent on the alcohol.
To function normally.
Exactly. So when you stop drinking, your brain freaks out. It doesn't know how to function without it.
And that's when you get withdrawal symptoms.
Exactly.
This is all pretty intense.
It is. It's a complex process.
But I'm glad we're talking about it.
Me too. I think it's important for people to understand the science behind addiction. It helps us break down the stigma and see it for what it is.
Yeah, disease.
Exactly.
So what's next? What else do we need to know about alcohol in the brain? All right, so we're back for the final part of our deep dive into alcohol and the brain. And I got to say, I'm a little apprehensive. We've talked about how alcohol affects different parts of the brain, how it messes with neurotransmitters. We even touched on addiction and the role of genetics. But now it's time to face the music, right? The long-term consequences.
You're right. It's the elephant in the room. But it's a conversation we need to have.
Okay, I'm ready. Where do we start?
Well, we've already talked about some of the long-term risks, like shrinkage of the hippocampus.
Yeah, the memory center.
Exactly. And I think it's important to really understand what that means for people. Like, what are the real-life consequences of that damage?
Yeah, paint me a picture.
Imagine you're trying to learn something new, like a new language or a new skill, but your brain just can't seem to retain the information.
Oh, you're like when you're studying for a test and you just can't remember anything?
Exactly. Or you meet someone new and forget their name 5 minutes later. Or you walk into a room and forget why you went there.
Wow, that sounds really frustrating.
It is, and it can be incredibly debilitating for people. In severe cases, it can even lead to a type of dementia.
Dementia from alcohol.
Yes, alcohol-related dementia.
That's terrifying.
It is. It's a very real and serious consequence of chronic heavy drinking.
So it's not just memory problems. It's like losing your mind.
In a way, yes, it can affect your thinking, your personality, your ability to function in daily life.
And what about Wernicke-Korsakoff syndrome?
Right, we talked about that earlier. It's another serious neurological condition linked to alcohol abuse.
It's the one caused by thiamine deficiency.
Right, exactly. And it can cause persistent memory problems, confusion, difficulty with coordination, even vision changes.
So how does alcohol actually contribute to thiamine deficiency?
Well, it interferes with the body's ability to absorb thiamine from food. It also impairs the liver's ability to store and utilize thiamine.
And to make matters worse, a lot of heavy drinkers don't have the best diets.
Right, which further depletes their thiamine
It's
levels.
like a vicious cycle.
Exactly. And without enough thiamine, certain brain regions can't function properly, leading to those severe neurological symptoms.
So it's not just the hippocampus that's vulnerable to long-term damage.
No, unfortunately not. Chronic alcohol use can also lead to shrinkage in other areas of the brain.
Like where?
Well, one area of significant concern is the frontal lobes.
The frontal lobes.
Yeah, they're basically the executive control center of your brain.
So like the CEO of the brain.
Exactly. They're responsible for planning, decision-making, impulse control, social behavior, all those higher-level functions that make us human.
And alcohol can damage that.
It can. Over time, heavy drinking can lead to shrinkage of the frontal lobes.
What happens when the frontal lobes are damaged?
Well, people might become more impulsive, have poor judgment, struggle with emotional regulation.
So they might make riskier decisions, have trouble controlling their anger.
Exactly. They might also have difficulty thinking abstractly, solving problems, adapting to new situations.
It's like alcohol is chipping away at our ability to think clearly and make good choices.
That's a good way to put it.
And this damage, it's not always obvious.
Right. It can develop gradually,
Yeah.
so people might not even realize it's happening.
Until it's too late.
It's important to be aware of the risks
Yeah.
and to seek help if you're concerned about your drinking or someone else's drinking.
Okay, so we've talked about all this damage. But is there any hope for recovery? Can the brain heal itself after all this?
That's a great question. And the answer is, it depends
On what?
on a lot of factors. The severity of the alcohol abuse, how long it went on for, the individual's overall health, their genetics.
So it's not a one-size-fits-all answer.
Right. But the brain does have an amazing capacity for healing. It's called neuroplasticity.
Neuroplasticity.
It means the brain can adapt, rewire itself, even repair some damage.
So if someone stops drinking, their brain might be able to recover.
It's possible, especially if they stop early enough.
So early intervention is key.
Absolutely. The sooner someone stops drinking, the better their chances of recovery.
This has been a lot to process.
It has.
But I'm really glad we had this conversation. I feel like I've learned so much about the real impact of alcohol on the brain.
Me too. And I hope our listeners feel the same way.
I think it's so important to be informed about these things, to make conscious choices about our health.
Absolutely. Knowledge is power, as they say.
And sometimes knowledge can be a little scary.
It can. But it's always better to know the truth.
I agree. So what's the takeaway message here?
I think the takeaway is that alcohol is a powerful drug. It can have both short-term and long-term effects on the brain. And it's important to be mindful of those effects, to drink responsibly if you choose to drink at all, and to seek help if you're struggling with alcohol abuse.
Well said. I think that's a perfect note to end on. Thank you so much for joining us on this deep dive into the complex world of alcohol and the brain. We hope you found it informative and maybe even a little bit eye-opening. And remember, if you're concerned about your drinking or someone else's drinking, there is help available. Don't hesitate to reach out.
Absolutely. There's no shame in asking for help.
Thanks again for being here.
It was my pleasure.
Until next time, stay curious, stay informed, and stay healthy.